Thank you very much for having us. We're going to have a great conversation today, but before jumping into it, I'd like to share some of our experience with building a unicorn in Europe. So, what if I told you that Europe is going to be a natural leader in AI? What if I told you that regulation is going to be one of our strongest competitive advantages? A lot of what if, right? Let's jump into it. So I spent 9 years building this company in Europe. We have 150 people on the team. Initially raised 70 million, now investing more than $1 billion to build infrastructure in Europe. And what I have learned is that at the end of the day, AI is two things. It's a system for generating efficiency, and it's a system for reinventing business models, innovating. And then there is a third piece, generative AI. Well, generative AI is being pictured like a flying car today. But I strongly believe that it is no more than an electrical car with limited autonomy. It is going to be a flying car, but it is not today. So what this frames for us, what this frames for Europe, is a different timeline and the path and the mindset to get there. So after training foundational models, implementing this into POCs, working with customers, the best definition that at Domin we have for generative AI is an exploration system. What is generative AI? What is a foundational model? Is a file. Think of it at the simplest possible form. It's an artifact like a Word document, which through a very sophisticated algorithm, the transformer architecture, can blend more than 20 trillion words into that file and make it talk like a human. Now, we have managed to use the same technology for video, images, so on and so forth, but this is what it is. And it is so simple and so complex at the same time. So another way to frame it is that it is the closest thing to chemistry that we have ever seen. It took us more than 2,000 years to consolidate chemistry into science and to make it predictable to some extent, and we're still working on it. So now it is not going to take us 2,000 years to get Gen AI right, but it is going to take time. So what is the opportunity for Europe? At Domin, again, we believe that this is the knowledge revolution. And this is not getting closer to the internet revolution or to the personal computer revolution. This goes back as much as 500 years to the Gutenberg revolution, to the printed press. And when we think about how can we use this in a way that will create a competitive advantage, will become useful, of course, software 3.0 is the obvious choice. But if we wanted to be a little bit more dreamy about this, we believe that this is the new tool that accelerates the human intellect. And if you connect that with Europe, Europe is actually built around intellectual property, which is at the heart of democracy, which is at the heart of individual freedom. So this is why it is important to regulate. This is why it is important to be a sovereign technology. Then we can think about the applications, but this is the potential, this is the opportunity for Europe. First of all, to defend the intellectual property proposition that makes Europe what it is today, and that makes possible for our deep history to actually be somehow turned into the future. And on the other hand, to make it right for people. Because if we centralize this technology in the hands of a few, if the intellectual property is owned by one company, it doesn't matter where it sits. It can be Silicon Valley, it can be Europe, it can be China. It is not right for people, because it will impact individual freedom. And when we then think about how can we apply this into the real world, I like to present this citation from my favorite philosopher, John Locke, which says that knowledge comes from experience alone. What Gen AI is enabling is a revolution of knowledge, which then results in a revolution of experience, revolutionizing the human experience. And of course, we're starting with software. Software has eaten the world. Software is the operating system of the world. If we stop software, we stop infrastructure, we stop healthcare, we stop finance, we stop everything. So the first obvious use case is the revolution of the user interface. And again, here we're stressing a lot about the fact that the game has been won because who owns the user interface today? Search engines or US hyperscalers, since they now got AI and they just transformed it into the new user interface, we lost the game. Actually, this is a much more sophisticated market. So I brought this table from Bloomberg together with some other market researchers, which have actually provided a quite good breakdown of that 1 trillion plus opportunity that everyone is mentioning when they talk about the opportunity of Gen AI. And this is not 1 trillion in market cap. This is 1 trillion in revenue. And if we look at the split of how the IT market generates revenue today worldwide, Europe can capture at about 350 billion in revenue by 2032 by just owning one of these or a portion of these subcategories around Gen AI. It's a lot more than just the foundational models. And this is a huge opportunity. On the other hand, let's talk about safety as well. So the opportunity is clear. On one side, we have data. On the other side, we have users. And we're trying to close the gap. Because since software is the operating system of the world, we want to innovate it. We want to make it more inclusive and more democratized. But at the same time, the promise is not real. It doesn't fit with the real world. Because the idea that generative AI is promising that we can just use an LLM to close the digital divide between data and people is not just real. And everyone that's working in IT knows this. A lot of people, I'm sure, from this room have actually experienced what they're seeing on the screen right now. Before the LLM and after the LLM, you need 90% of software. You need 90% of system integration to make it work, to bring it into production. I mean, of course, we're writing text, we're generating videos, we're doing these amazing things that have an impact, and we jumped from, hey, Siri, call my friend, and it was calling, my brother, to this beautiful experience that talks like a human. But the world is much more complicated than that. Think about your money being managed by your bank with a system that hallucinates. Think about the energy company that runs the backbone infrastructure of our country, our region, that leverages these systems. It's absolutely not acceptable. And there are numbers that back up this. So actually in the US, they lose more than 2.4 trillion a year because of the quality of bad data and bad software. So there is a huge opportunity beyond generative AI that we as Europe need to look at, find the white spaces, and generate value. And we need to embrace this digital renaissance, which designs the ecosystem of software from scratch. And from our experience today, if we had to find one single systemic trigger that generates a competitive advantage for Europe, that is compute. That is not foundational models. When we started training our foundational models, we had to knock the doors of hyperscalers and beg them to give us GPUs. Because this is the situation that we faced. Basically, the largest HPC system in Europe is 15 times smaller than what OpenAI used for GPT-4, which by now is an old model as they got out with GPT-5. So the whole of Europe has 15 times less compute than one private company in the United States. We can have a long conversation about the data, we can have a long conversation about regulation, we can talk about talent, but if we don't have this, it will never happen. So this is what we need to do, in my opinion. Have a clear strategy that is based on facts and that is not stressing about the time. We have time. We know where the problem sits. We have the tools to solve it, and we just need to do it. I borrowed some slides from NVIDIA also to show you why sometimes being late is also good. So actually, NVIDIA with this slide is showing how these supercomputers are the factories of the future. And we, in Europe, especially here in Germany, we know something about manufacturing. Now, we're not talking about manufacturing cars anymore. We're talking about manufacturing intelligence. The example they make here is more generic. They're saying that manufacturing intelligence is similar to manufacturing electricity and energy. Now, the interesting thing is that while compute has grown by more than 1,000 times in the last 8 years, And this has been disrupting most of the great ideas in Europe, because as we moved from one year to the other, we didn't have the chance to catch up. Energy, on the other side, has been, the need for energy has been reduced by more than 25 times. So today, we can actually deploy a machine that produces 30 times more compute with 25 times less energy consumption at scale here in Europe for, you know, a few $100 million instead of a few $1 billion, which was last year. So there are these opportunities that we need to absolutely account when we think of the future of AI in Europe. And let me get towards closing this with the fact that, you know, we should not only think that we should not at this point try to be a first mover. We're not a first mover in AI. I believe we should not even be a second mover. We should look at this as a third mover advantage. And let me make an example of how this worked in the future for Apple becoming Apple today. So Olivetti, a company from Italy, was designing products back in the days, these printing machines. And at some point, they invented a machine just by mistake, just like it happened with ChatGPT. And they unveiled it at the Fair of the Future in New York in 1965. They sold 40,000 pieces, and it seemed like they dominated that market. They created a whole new category. They were the first mover. 40,000 businesses were using this for their point-of-sale system in the US. Then HP, which had a much better distribution, compared this with hyperscalers today, just copy-pasted everything, literally. Now, I didn't write it on the slide, but I like to say it because they had a very clear strategy. They understood that there was an opportunity to actually get Programma 101, which was the product of Olivetti, and scale it much faster. And they did it because they had more resources, which is what we don't have as Europeans today. Then Apple came, and we all know the story, right? They put a beautiful screen on top of that box, and this is what made Apple Apple. They were creative. They think differently. So let's be the Apple of this generation for AI and not think about catching up. Another thing is about artificial general intelligence. This is, I think, the topic that is stressing us all because we believe that actually artificial general intelligence is going to be done by one company, and that company should have unlimited resources. Not only that is not true, but it is also wrong. Because we believe that artificial general intelligence is going to be all of us. It's going to be a composite system that represents the world where diversity is going to be crucial. So it is okay for China to invest in efficiency, Europe to build a proposition around trust, and the US to actually invest more in scale. Because the composition of these puzzles, of these pieces, will bring us to generative AI being more balanced and more equal for all of us. So now I have plenty of use cases, but we're running out of time, so I'm going to keep them for the conversation because we're doing some great things in Europe. And one of the things that I will present just quickly before starting the conversation with Christian is that we started in 2016. We invested 3 million working hours in engineering a platform that today we're selling to regulated industries like governments, banks, defense organizations, and advanced manufacturing companies. We've been doing this quietly, and you know, it can be done in Europe. We went from building foundational models to building our own agentic AI system, which is fully independent from third parties, to now building one of the largest supercomputers in the world. So with that, I just wanted to say, be confident, because there is a chance for Europe not only to participate, but I think to naturally lead the game. Thank you.
Thank you, Richard. And this is, I think, you know, you have actually many encouraging messages for Europe, right? And the first is obviously that, you know, we don't have to be the first movers. We don't have to be the second. It's okay to be the third, right? And basically also leverage some lessons learned. But at the same, and then the other, I think the other message that is, you know, is very important and it's also good to see is that Europe is actually more than just Paris or London or Berlin, right? You have basically started, you know, your company in Milan. Tomorrow we will have examples from Valencia here on stage as well. So I think Europe is way more than just the big hubs. But you know, let's talk about sort of the elephant in the room. I think the elephant in the room today was how can we scale, right? So how can we build businesses for Europe that can compete for the big tickets when sort of a Siemens or a big car manufacturer has a big tender out there for, say, 100 million revenue. How can we get there?
So these have been my board conversation for the past 5 years, right? So how do we find a way to build a 1 trillion plus big tech company in Europe with global ambitions? And of course, we made mistakes down the way, and one of these mistakes was sometimes trying to compete on performance. It was not a matter of catching up, but even though we were going, for example, to build vertical AI instead of general AI, to put together foundational models with European industrial expertise and then create that sort of value proposition, it still was not enough. Because the game of performance is always going to be won by who has more resources, and also the first movers have a competitive advantage because they own the mind share of the market. So when we started looking at this problem, the solution that we came up with was find white spaces that are opposite business models to the performance game. For example, if you look at how hyperscalers work, there are some use cases that they are not able to run because of the nature of their business. AWS or Google, they would never open the source code of their native services in the cloud because that would be a security breach for them. That is worth much more money for them in terms of risk. The risk is so high that they prefer to not do it. So if you were to serve regulated industries with a truly sovereign system that they need to fully isolate and own down to the single line of code, then you need to have an opposite business model to that, because you need to not only build a foundational model, not only to make it open, but also to transfer the ownership of that model to the client. So I think when it comes to scale-ups, dreaming towards $1 trillion plus in market cap and building a very successful company that is living on top of systemic growth, you need to find these white spaces and build around them.
And then that's basically what you think we should do, right? Focus on certain domains, on certain white spots, and then be competitive because ultimately you compete with a Microsoft, with a Google.
Yes, and connect it with space and time. For example, we did it with the models. We are able today to transfer a 350 billion parameter model that we trained with an investment of 50 million euros for free to a client to enable them to connect data that they cannot connect with other LLMs. And then on top of that, we're able to sell software and build a business model. But we also did it with the supercomputer. We'd never built a data center before, but we started asking ourselves, how can we do this better? What is that the hyperscalers are not able to deliver today? For example, we discovered that they have sites that were not designed for liquid cooling, and they were not designed for hosting some of the most recent innovations in chip installation and AI compute. So we're able to cut the cost by 50% by actually designing this new type of data center. So looking at these white spaces is very complex. You need to do a lot of research, but we believe there is a strong opportunity for Europe, to build at least 4 or 5 1 trillion organizations by just serving the white spaces.
And when I think that there was a chart you went over pretty quickly, but I think this is mind blowing when you think about the fact that when OpenAI trained ChatGPT, they had access to compute power that was 14, 15 times larger than the entire Europe together. So how do we deal with that? Is that something where we have to close the gap, or is it okay that the gap exists and we just find a smarter way like you guys have sort of started to do?
Do we need to close the gap? Yes, absolutely. Otherwise, there's not going to be any European AI. Do we need to make it extra large and compete on performance and look at that 500 billion investment that the US is doing with Stargate like, oh my God, the game is done? Absolutely not. It doesn't have to be small or big. It's just about the right size. Understanding the science behind it. For example, we sized our investment at 1 billion because we needed about 100 billion operations per second, because this is how much compute you can leverage in parallel to train models in an efficient way. If you go beyond that, the software will break, so the time that you are losing in actually restarting your training jobs will result in no efficiency, so it doesn't make any sense. And I would love to actually show this supercomputer, because again, I showed a lot of slides, but also love to show something that we're actually building. So I don't know if we can bring it up in the screen. So this computer actually, just to compare it with the numbers that we were mentioning before, is able to deliver 170 times. When we designed it initially, it was 115 times larger than the largest supercomputer in Europe until last week, because Germany broke some new records last Friday. Because the Jupiter actually launched the cluster, which is the first exascale system in Europe. We're still building what you see in the screen. So this supercomputer is called Colosseum. It's a private investment from Domin. And it's a fully containerized system. So we thought of hardware like software. So what you're seeing right now is basically containers that we're producing around the world. And that starting from the end of this year, we're going to start putting them together, being able to achieve early next year 170 billion operations per second. So we'll be able to train a model of the size of ChatGPT, so even if we think of GPT-5, in about 45 days. So we can produce every 45 days a model as big as that from the most recent release of OpenAI, because this machine is designed for 1 trillion parameter plus models. So I think we have a lot of time. We need to be conscious of these investments, because we do not have a chance to make this wrong. I mean, when we talk about we need more funds in Europe, we need more VCs, we need more courage. At the same time, we cannot invest 200 billion and fail.
No.
So we need to build the success, we need to build the confidence, and need to build the culture. So this is why this needs to be facts-driven and not based on hype.
And one very last question. We are running out of time, Uljan. You talked about what we need. Do we also need more cooperation across Europe? More Airbus approaches?
I think that is what we're missing today. We're missing the critical mass of people, the most brilliant minds and companies we have in Europe, to build that single big case study. You called it Airbus of AI. I think that's a perfect definition, because that would enable us to create the gravity and to create the dream. Because let's face it, people don't believe this can be done in Europe. I spent half of my time every day with, sometimes unfortunately also investors, not only customers and friends. They are like, what are you doing in Europe? This company would be worth 100 billion in the US. And I was like, I don't care. I'm not doing this for money. I would not even accept a blank check. And also I accept the idea that building in Europe means more tears and it means more blood, because it's just a matter of accepting reality. We need to be realistic. For example, the US now, the president of the United States, it's desperately doing all sorts of moves to turn the United States into a manufacturing industry. This is if you compare it with what Europe is doing on AI, it's the same thing. So we are just on a different stage of development on the timeline of the market for AI, but we are much more ahead for manufacturing, for example. So if we can find a way to balance these strengths with the weaknesses and to be really thoughtful about the future, I truly think we can lead in AI. First of all, because we need this for us. We have tried for many years in Europe to have one model that fits them all. It is not going to work. If we want one single market in Europe, AI is our chance, because AI is the best translator of complexity. By implementing AI in Europe, we are going to create the most powerful economy the world has ever seen, because that is going to multiply the capital markets in Europe by 50x. So if today we are about to be the second or third economy, imagine if we multiply the valuation of our industrial companies by 50x. Why Tesla is worth 1 trillion and our car companies are not worth 1 trillion? Because they are not tech companies. They're not AI companies. So when I think about the use case, and I think this is the main takeaway I would love to leave with this room, let's not think about AI as a system for efficiency. Everyone can do that. Let's not think about AI to cut 5 minutes of time and turn our companies into more productive companies. Let's think of AI as a product. Let's turn every company in Europe, every government in Europe into an AI organization. This is what will make us a leader in AI.
Thank you so much, Olcan, for coming. I think that's I think we leave the audience with that closing statement. I think that was perfect. Thank you so much.
Thank you.